take the adiabatic process time now then. No? Okay, we'll do one thing. Isobaric, I'll take it. It's a process in which pressure is constant. Then Q equal to delta U plus W. All three will be non-zero. Pressure constant, so PV equal to nRT, pressure constant. So therefore, let me calculate work done. Integral of P dV. Pressure constant, so nRT P dV. Let me write here. So from ideal gas equation, PV equal to nRT, pressure constant, volume changes. Temperature should also change. So therefore, in place of P delta V, what you can write? nR delta T. Substituting this, nR delta T. Let me write here Q equal to delta U. In place of W, I'll write nR delta T. So what is delta U? nR gamma minus 1 delta T. nR delta T outside 1 by gamma minus 1 plus 1. Or Q equal to nR delta T gamma by gamma minus 1. Anybody gamma by gamma minus 1, what it can be? Okay, let's do one thing. We know gamma equal to Cp by Cv. Agree this? So therefore this Cp, what you can write? Gamma into Cv. What is Cv? R by gamma minus 1. So let me rewrite this. N delta T R gamma by gamma minus 1. From this background, gamma R by gamma minus 1, what you can write? Cp. So therefore, in isobaric process, what is Q? Q equal to NCP delta T. They're the one thing. Next again, how Q and delta U are related. Let me proceed further. We know delta U equal to what you can write? NR delta T by gamma minus 1. Okay, let me, as we know, Q equal to delta U plus W. NR delta T, I can write it as delta U gamma minus 1. Very important numericals, plenty of numericals. Every time you need to derive. In isobaric process, how Q and delta U are related. Q equal to gamma delta U. One more formula, Q equal to NCP delta T. There's one more formula. Okay, now how Q and W are related? Let's check it. How Q and W are related. How W and delta U are related. That also will see all the things. So next again, I know delta U. So relation between W is equal to nR delta T. nR delta T, what you can write it as, already we know, it should be equal to delta U gamma minus 1. Okay, there's one more equation. In isobaric process, work done by gas is equal to gamma minus 1 into delta U. See this. Okay, Q delta U, we got it. W into W in terms of delta U. Q in terms of change in temperature. Q in terms of W, I want. Delta U, what you can write it as? Q by gamma. Or here only delta U. Let me write it as Q by gamma. There's one more equation. In isobaric process, there's a relation between Q equal to gamma delta U. And what is a gamma? Cp by Cv. Already we have said adiabatic exponent of gas, that one. How pressure of gas can be constant? How it is possible? Now the gas will undergo the process such that the pressure of gas will be constant. So there's a path you can see now. The gas has undergone process, the pressure of gas is constant, the volume is changing. So this is called like a isobaric expansion or isobaric eating. What is this process? This is called like a isobaric eating, it is called as. Pressure of gas will remain constant, will not change. Isobaric eating. Now, how do we can maintain pressure of gas constant? Yes, very simple. I'll go back to again cylinder. There's a cylinder. There's a piston. Already we have come across this. The same diagram is what I'm going to put it. Now look at this. Weight mg. The same story. P naught A, pressure of gas, PA. mg. P naught A, pressure of gas, PA. Look at what is the expression for pressure of gas. PA equal to P naught A plus mg. So P naught constant, all constant. So therefore, what is the P? Pressure remains constant. I will supply now heat. Volume V1, temperature T1. Volume V2, temperature T2. How the piston? Piston will move gradually, not sudden. If piston accelerates, then what happens? The pressure will be varying. So it's not possible. So therefore, the piston move with a uniform velocity, also gradually. Then it's said to be undergoing isobaric process here. On its own, the gas will not determine, the gas will not decide that what process it should undergo. The external agent should create conditions for the gas to undergo that particular process. The gas means here it's ideal only. So what is the Cp molar capacity? Shall we define dq by n dt? Now, what is the dq? Ncp dt. So what is the molar capacity of a gas now will be a constant. So what this gas will do when you supply heat, a part of it is utilized to increase energy, remaining is utilized to do work. In isobaric process, what gas does? In isobaric process, heat absorbed by gas is converted into increase in intensity of gas and mechanical work done by gas. T2 must be greater than T1. Definitely no. I will bring that mathematics for that also. Okay, these are both things. Okay, let's come for ideal gas equation. PV equal to nRT. So P1, so P constant, so V1 nRT1. So therefore, what is the equation we can write? V1 T1 equal to V2 T2. So therefore, if you plot volume versus temperature graph, if you plot volume versus temperature graph, and if the straight line passes through the origin, what is that process will be? It must be isobaric process. Sorry, it must be isobaric process. Getting this will be V1, V2, T1, T2. Different types of graphs. PV graph we have seen. There's a VT graph. Let me put all the graphs at one place. It'll be easy for you. Comparison. Okay, no. So in isobaric process, volume versus temperature curve. If a straight line passes through origin, it's isobaric process. Strictly, it should pass through origin. I think you know mathematics now. I know PV graph. In PV graph, how the curve. Straight line, horizontal line, isobaric process. Okay, this is about the volume versus temperature, pressure versus volume, temperature versus pressure graph, vertical line, anything, either vertical line it should be. Then it should be a, definitely it should be a isobaric process. Pressure constant isobaric, that's all here. Now, here, internal energy versus density. What about intensity versus density? I'll say rectangular hyperbola. So now you can say rectangular hyperbola will be isobaric process. So let's do one thing. Let's take help of mathematics. Euro constant. What is intensity? Depends on temperature, no? So shall we write nr gamma minus 1t? What is the density? Or you write density? Density equal to mass by volume, mass of gas by volume. So constant, let me write it as alpha. Okay, let me write T by V is equal to alpha gamma minus 1 nrm. Let me use ideal gas equation. PV equal to nRT. So in place of T by V, what we can write? P by nr. Finally, what I ended up. So look at pressure, alpha, gamma, m. So therefore pressure is a constant. So in intensity versus density graph, a rectangular hyperbola will be what like? Isobaric process. In VT graph, straight line passing through origin. In PV graph, horizontal line. TP graph, vertical line. Now, books, we have this, all these things in numericals, but in numericals, rather than struggling in numericals, better let's struggle now only, no? Rather than fighting in numerical, let's have some background. Sorry, you have plotted intensity versus density. Pressure versus intensity graph, how it will be? Or intensity versus pressure. Vertical line. Oh, sorry, okay. Already intensity versus, okay, this intensity versus pressure versus intensity. Let me take it. The same idea will be same, no? Able to make it out. So don't just only end up pressure, volume, pressure, volume. So I may force you to any of the graphs here. Not only this, I may force you to think on any of the possible graphs. Say student must analyze all the possible graphs here. So what are all possible graphs? PV graph, PV graph, PT graph. So able to think, no? So this isobaric process, the pressure of gas will remain constant. Then what is the molar capacity for this gas will become equal to Cp. Of all, this is very important. So this is called like isobaric heating, temperature increases. If arrow downward, temperature decreases. Isobaric cooling, it is called as. So temperature in isobaric process, temperature increases, isobaric heating, temperature decreases, isobaric cooling. See, everyone knows isobaric process, pressure constant. Let's do understand what is the process. What do you mean by process? Once again, let me summarize. What do you mean process? Where the gas, where the parameters of gas will undergo changes. That is called like a thermodynamic process here. Parameters of gas should undergo changes. What is that? Pressure, volume, temperature, intensity should undergo some changes. Then only it's said to be thermodynamic process here. What do you mean by path? How that parameters will vary with each other. We do express that graphically, and that particular curve what we plot, no, that is called like a path. Or practically how you move the piston, that will determine the path. If piston moves with variable acceleration, what will happen to pressure? Will change. Then it cannot be isobaric process. How you move the piston will determine what process the gas will undergo. Are you able to understand now? Hope you should use your mechanics clearly here. If the piston moves with a constant speed, pressure will be constant, isobaric. Piston accelerates, uniform acceleration, then also pressure constant. If the piston moves up with a variable acceleration, then pressure will continuously will increase. Then it cannot be isobaric process. So therefore, you have to supply it in such a way that it should move either with uniform speed or uniform accelerated motion. Getting the idea? The methodology? So therefore, gas will determine that I should undergo this process. No. X agent is going to determine what process the gas should undergo. Example, this isothermal. Why temperature of gas constant? Why the temperature of gas is constant? We are going to maintain, if I maintain temperature of gas constant, it will be isothermal. Otherwise not possible. The gas will not determine what process it will undergo. The external agent, what happen, is going to define what process the gas should undergo. Are you getting? No? So we think that gas is dynamic. Gas is what? Some sort of just like a lifeless matter. No, it is what process the gas should undergo will determine the external agent. So how you move the piston, a good example here. I'll supply it. Then if the piston moves in such a way the temperature of gas constant, how to maintain temperature of gas constant, that is what I should do. Then it will undergo isothermal process. Then if temperature constant, then you supply any amount of heat, it will convert into mechanical work, or you move the piston gradually. Then what gas will do? It will convert mechanical work into heat. Suppose say this is a winter, I want water will be cold. I want to take bath early morning. So I need hot water. So shall I use this mechanism? I'll move the piston. I'll do mechanical work. So what gas will do? Will convert mechanical work into heat. That heat, what happen? Will be given to cold water. It will become warm or hot. I'll take the bath, hot water bath. Very simple way. So can I use this cylinder, piston, and gas to generate heat? Yes, I should supply energy. So what this gas is doing now, converting mechanical work into heat or heat to mechanical work. There's the meaning of this. Vice versa. Mechanical work will be converted into heat or heat to mechanical work. So there's an arrow is what you have to show it. Fine. So these are the ways in which a student should, and always the background should undergo this one. Sir, here, what actually going on? What is this? You have a cylinder and there is a piston. Okay, and what will happen? You are supplied heat in such a way that what will happen? Okay, okay, this what is this isothermal process? No, it is. Okay, this is for isothermal. No, I thought. Yeah, let it be this one. No, I supplied heat and the piston will move in such a way that